Okay, so in this video we're going to take a look at how a loudspeaker works, and this is a really nice example of the motor effect, where essentially we have two magnetic fields, one of which is an electromagnet, interacting with each other, and that exerting a force on them and making them move. So a loudspeaker is a classic example of that. So what we've got over here is an AC power supply. So what this means is sometimes this is sending the current out of this red one here, and sometimes it's sending the current out of this black one, and sometimes it's sending no current at all. And we actually produces what we call a sinusoidal pattern. So if I just sketch what the current looks like here, so if I were to sketch a graph for the current, so this is current versus time, an AC power supply is producing a current that looks like this. So sometimes the current is coming out of one side, sometimes it's coming out of the other, and it's constantly changing direction. And this cycle, like this, is happening 50 times in 1 second. That's what we mean when we say electricity is 50 hertz in the UK. If you go across somewhere like America, they actually run their electricity on 60 hertz, but at a slightly lower voltage. But this is what our AC power supply is doing. So this is important because what it's going to do is it means the electromagnet, which we're going to connect to it, is going to be constantly changing direction. So if we do a sketch of that, so let's draw ourselves a coil, and let's say we're putting a soft iron core through it as well, which we probably are, and then we have the current coming out the other side. So during this phase, so let's call this phase 1, this will be a north pole and this will be a south pole. So this is what it's like in the phase 1. Let's call this one phase 2. Again, we've still got our coil with a current going through it, still got our soft iron core, but this time we've got north and south reversed. So during phase 2, because the current is going in the opposite direction, the magnetic field is reversed around here. And this is going to be key for a loudspeaker. So a loudspeaker needs an electromagnet with an AC current. So that's what we've got here. So the AC is provided by this power supply here. There is also a permanent magnet inside this particular part of your loudspeaker here in the middle. So there's actually a permanent magnet, maybe something like one of these, inside here. So effectively what we've got, so we've got an electromagnet made with a coil of wire, and we've got a permanent magnet in there. And those two are going to interact with each other to produce a force. And if I turn it on, so I'll lean in a bit closer so you might be able to hear it. So what's happening is this drum here is going up and down, and it's going up and down in that cycle 50 times per second. And the reason for that is because of this magnetic field change that we have here. So maybe in this configuration here, it makes the permanent magnet jump upwards. And in this one, it will make the permanent magnet go downwards. And that oscillation is what creates the vibration in our loudspeaker. So if that's the case, I'll just turn that off, we should be able to build one of these for ourselves and set that to work. So that's exactly what we'll do. Or more precisely, I'm going to show you one that I've actually made. So we have created very much the same thing. So this cone is like the essentially this part of the loudspeaker here. So that's the role that's playing. You can see we've got this green wire in here. So this is going to be our electromagnet. So let's connect that up. Okay, so we've got our electromagnet, we've got a cone, we turn it on, and nothing happens. Why? Because we haven't put a permanent magnet in there yet. We need something that's going to be affected by this electromagnet. So let's do that. So we've got a permanent magnet here. Let's pop that in there. And then we'll sit that up as best we can on this desk. I think I'm going to have to hold it here. So inside here, we've now got a permanent magnet. Now this isn't switched on, so nothing is happening. So this electromagnet doesn't currently have a magnetic field because there's no current. So when I turn on the AC power supply, we've now got an electromagnet which is constantly changing direction. And that should make our permanent magnet inside it jump up and down, and let's see that in action. So you should, well, I said see, so you should be able to hear that in action. You hear that annoying rattling sound. That is caused by the magnet jumping up and down on the loudspeaker. So we've created for ourselves a very basic kind of loudspeaker. Now, that one you can hear, but you can't see it particularly well. So let's actually switch that for something you can actually see. Okay, so what we're going to do is we are going to change the electromagnet a little bit. So our electromagnet was a coil. We'll now change it for something that we can see a little better. So we're going to turn this foil into an electromagnet. We're going to give ourselves a nice big permanent magnet there. So that's what this is there for. And then again, we're going to need to actually put a current through our foil. So let's do that. Let's connect that in that end. And let's connect this one in this end. So what we've got here is this foil is now our electromagnet. We've connected it to our AC power supply. So essentially we're putting a current in, sometimes going from left to right, sometimes going from right to left. And we've got a permanent magnetic field, and its field is sort of in this direction here, because we've got north on one side and south on the other. So the field is in this direction that way. And the current is coming across sometimes that way, sometimes that way. So if we use our Fleming's left-hand rule here, so our first finger is going to be pointing in the direction of the magnetic field. If the current is going from left to right, we can see it'll experience a force upwards. If the current is going from right to left, this one's hard to show on a camera, we're going to get essentially a force downwards. So what we should see happen is our foil should start jumping up and down. So let's actually get a close-up so we can see that in action, and I'll switch it on. And it's exactly what we get. You should be able to see the foil jumping up and down as the current switches direction in the circuit, and that produces a magnetic force sometimes up, sometimes down, so you get this oscillation. So this is another way of showing essentially your loudspeaker effect. So we're seeing the effect of our electromagnet constantly changing direction, and that changes the force that it exerts on the other part of the system here.